the dark side of the universe. Not the one from Star Wars, anyway. Dark matter is a hypothetical form of matter that is thought to account for approximately 85% of the matter in the universe. What we call normal matter, which is what we are made of, is just a 15% of the matter in the universe. Anyway, this 100% is just a 32% of the whole composition of the cosmos. The whole universe is actually composed by a 68% of dark energy, 27% of dark matter, and 5% of normal matter. Quick analogy: if the universe was a pizza that, for some reason, we cut into 16 slices, only one of them would be normal matter, 5 would be dark matter, and 10 would be dark energy. Continuing with the subject. Astronomers can't see dark matter directly, but can study its effects by looking at the gravitational effects it appears to have on galaxies and galaxy clusters. This is actually very important in physics. Many times, scientists discover things by looking at how something affects its surroundings, because it may be impossible to look at the something sometimes. The reason why we cannot see it directly is that it does not appear to interact with electromagnetic radiation, such as light, so it is invisible to the entire electromagnetic spectrum. This means it does not absorb, reflect, or emit any light, making it extremely hard to spot. That is why we call it dark matter, actually. Don't get confused, anyway, this does not mean dark matter is black. Now, what are these gravitational effects? When scientists first measured how the groups of galaxies moved in the 1930s, and weighed the amount of matter they contained, they found out that there was not enough matter in these groups of galaxies to be held together. Later, more observations confirmed these results. There was not enough matter to provide enough gravity to hold these galaxies together. So, scientists said, there must be some stuff out there that we can see. Nowadays, we call that stuff dark matter. Later that century, more things were discovered. Physicists had assumed that the attractive force of gravity of all these galaxies should slow down the expansion of the universe over time. So, two independent teams tried to measure the rate of deceleration of this expansion. Anyway, they found out the expansion was actually speeding up, which didn't make much sense. So, that's when they realized that there was one more thing out there we could not see. Maybe an unknown kind of energy that, instead of keeping things together, pulled them apart. Nowadays, we call this energy dark energy. And this dark energy is hypothesized to spread throughout all of space, tending to accelerate the expansion of the universe. Thanks to math and lots of observations, we now know that the universe is, as I said before, composed by a 68% of dark energy, 27% of dark matter, and 5% of normal matter. We're not sure of how dark energy behaves, or what's the composition of dark matter, and all of this matters.